Are you in the right quiz?
It was 96634.
U. That last one's a U.
Oh, okay.
All right, guys. So we're picking up where we left off before lunch. So now we've got this set up, but the middle part's not filled in. So we have to fill in the middle part and give the steps that we're doing as we go. So they're telling us we're starting with this and we want to end with tangent squared of x. Okay, so we're trying to prove that these are equal to each other. Okay, so again, you don't have to write anything in the first step. If you want to, you can just say given. Okay, so that's what we're starting with, the given information. I don't see much, like there's not like an algebra step I could do to simplify this. So I'm going to start by using my reciprocal and quotient identities here to change everything to terms of sine and cosine. So what is the reciprocal of cosecant? 1 over sine. So since this is squared, it'll be 1 over sine squared. And what is the quotient for tangent? What's that identity? Sine over cosine. So since it's squared, it'll be sine squared over cosine squared. Then we've still got the -1. Now, algebraically, well, let me go ahead and write there. I did 2 in one step, so I don't know if we're going to need all these spaces. We'll see. But I did reciprocal and quotient IDs. Reciprocal is the blue one, and the quotient is the pink one. Okay, now algebraically, what can you do now? Simplify because you've got a common factor in the numerator and denominator. So I can reduce. From here to here, which would make this 1 over cosine squared -1. Okay, what is cosine squared the same as? Or 1 over cosine squared, excuse me. Secant squared, right? Okay, so that is the reciprocal ID again. It's a different reciprocal ID, but it's a reciprocal ID. Then that entire expression there, secant squared -1, is tangent squared. What is that? That's your Pythagorean ID. Does that make sense how we did that? Okay. Let's do one more with the table to help guide us. All right, so we've got tangent of x plus cotangent of x, and we want to prove that that is the same as secant of x times cosecant of x. So we've definitely got to get rid of this plus. There's no plus in what we're working toward, right? So we're going to have to combine these somehow. A couple ways we could do that. Probably changing everything to terms of sine and cosine is going to be our best bet if you think about it, because that's how we can change from tangent cotangent terms to secant cosecant, because secant cosecant are the reciprocals of sine and cosine, right? So that's how I'm going to start. I'm going to change tangent to sine over cosine. And cotangent to cosine over sine. So that's step 1. That is quotient IDs. Now, to add or combine fractions, what do you have to have? A common denominator. What you practiced with numbers on Monday was if you can't turn one of the denominators into the other, you multiply them by each other, right? So I'm going to multiply this side by sine of x. And what you do to the denominator, you do to the numerator. And I'm going to multiply this side by cosine of x. So what that's going to give me over here, that would become sine squared in the numerator. Hang on, moves my stuff down all the time. Let me start with the denominator so it's on the bottom. My new common denominator is going to be sine x cosine x, right? And in the numerator, that will be sine squared plus, and then that's cosine squared. Okay, and what I did here was I got a common denominator and added the fractions or combined the fractions. So I did that kind of all in one step. If you want to do it in two separate, that would have worked too. Okay, but I got a common denominator to combine these to one fraction. Now, what do you see here? What's sine squared plus cosine squared equivalent to? Yeah, that's the same thing as 1. That is Pythagorean identity. Now, how is it they're going from 1 over sine times cosine to secant times cosecant? What are they changing there? What identity is being used? What's 1 over sine the same as? Cosecant. And what is 1 over cosine the same as? Secant. So they just did two reciprocal identities there. If you wanted to do them separately, you could. If you needed the visual of separating the fractions, if you need to understand that 1 over sine times 1 over cosine, if you needed to see it written that way to see that that 1 is over both of those denominators and they're being multiplied, you can draw that. You could have done that in an extra step in there if you needed to, but that's what's happening there. You'll feel okay about those? Okay. So we're going to do the check for understanding where they don't give us a table. They just give us the equation and it says verify that the expression on the left equals, or it on the left of the equal sign can be written as the expression on the right. So verify that these are equal. So I need to decide which side am I going to manipulate? Which side do you think is the more complicated side? The left. So I'm going to choose to work on the left side of this equation until I can get it to equal sine of x. I'm not going to move terms across the equal. I'm just going to work on one side. All right, so I'm going to start with cosecant. I'm going to rewrite as 1 over sine. We have a minus. We have cosine times, and then cotangent is cosine over sine, isn't it? So when you're multiplying these, cosine's over an understood 1, isn't it? So when you multiply 1 times sine, isn't that just sine? So that's all together over sine, agreed? Okay, So let me try and simplify that then, because I have a common denominator. I've got two fractions, both sine x as the denominator, so I can combine them. So what would my numerator be? Not just cosine squared. What's over the first term? My pen is acting up again. I don't know what the heck is going on today. What's this? Over this first term, when I did that substitution, let me highlight here. I substituted, instead of cosecant, I wrote it as 1 over sine. And then instead of cotangent, I wrote this as cosine over sine. But that's being multiplied by cosine, which has an understood one denominator. Okay, so when I combine this all together over sine of x, because that's my new common denominator, what's up and top? I'm literally circling it. What is this? A 1 minus, and then the cosine squared. We've got 1 minus cosine squared. Now, what is 1 minus cosine squared equivalent to? Sine squared. That's a Pythagorean identity. So if you go back, if you need to look back at your identities, you can have those to refer back to. What happens here? All of it? Are they exactly the same on top and bottom? No, on the top it's sine squared, right? One of the signs up here, because this is sine times sine, that's what sine squared is. So one of those sine factors reduces with the sine factor in the bottom, and you're left with just sine. Just the sign that's left in the numerator there. Which is what I was trying to prove that it equaled, right? That's what I was trying to prove up here, so it checks out. So when I ask you to verify, unless I have it like set up as a table, I don't need you to write every little rule down. I want you to understand what you're doing. But like here, I did the work, I showed it, but I didn't like make it in the form of a table and write all the rules. Does that make sense? Okay. All right, so last one. I want to work the left side. The left side's definitely the more complicated side. I want to prove that it equals cotangent of x. Okay, now right now, these do not have a common denominator. But I can get a common denominator by multiplying them by each other, right? So I'll multiply this side by cosine and this side by sine. Okay, that way the new common denominator would be cosine times sine. Y'all agree? So that's my new common denominator. And in top, what's cosine times secant? What's this right here? That's a 1. That's the reciprocal identity. Okay, so 1, and then we have minus, and then what's sine times sine? Sine squared. Okay, so let me show, this is the reciprocal identity. Now what? What's 1 minus sine squared? Cosine squared. That is your Pythagorean identity. Now there's a cosine in the numerator and the denominator as a factor. So one of the cosines from the numerator, so the square is going to go away with the cosine from the denominator, and I'm going to be left with cosine over sine, which what is that equal to? That's cotangent. Because that is a quotient ID. And is that what I was trying to prove that this equaled? Yeah, it matches that. So it checks out. All right, so tomorrow I'm going to be in a meeting and you're going to have time in class to practice this on your own. There's going to be a practice assignment for you. And then we're going to take a quiz on Friday.